So there are functions defined by integrals. Let's see if we can fill in the blanks here for big F here. We have, again, we're going from 0 to x of f of t, and notice that f of t is just a linear function here. In fact, it's a horizontal line. Okay. So let's see if we can fill in the blanks properly here. If we wanted the area from 0 to negative 2 of f of t dt, okay, then we would ultimately, again, keep in mind that we're starting at 0 here. If we went from 0 to negative 2, we'd be looking at that area right there, wouldn't we? True? And so ultimately, what would that area be? A 3 by 2 rectangle, so it would be 6. However, we're integrating from 0 to negative 2. We're integrating backwards, so therefore the answer should be negative 6. When we do negative 1, we're only going to have one block here, so it would be a 3 by 1 this time rectangle, so this would be negative 3. The area from 0 to 0 is always going to be 0. 0 to 1 is going to be 3. 0 to 2 is going to be 6. And 9, and 12. So if you filled in your blanks properly, it should look like that. All right. How about the answers to the questions then on what interval is f positive? Keeping in mind that this is little f, which is the picture that we're looking at. So on what intervals is f positive? Okay. Ultimately, if we think of this as a closed interval, it would be the negative 2 to 4. If it was an open interval, it's just a line y equals 3 here, so it would be always, okay, which would be a negative infinity to infinity. And since it doesn't tell us that we're only going from negative 2 to 4 only, they don't give us a closed interval, okay, then we'll consider the fact that we're just seeing part of the graph here and assume the rest does nothing different than what we see. Okay. On what intervals, if any, is f negative? So ultimately, that would be none. What intervals is big F increasing? Well, if we look at the values of big F, what's going on with big F? When is it increasing? Always. Decreasing? Never. Determine an algebraic rule for little f. We know that that's y equals what? 3. And an algebraic rule for big F. Okay. Great. Either from the antiderivative or from the values, what do we see here? What's going on? These points are linear, aren't they? Yeah, it's ultimately just y equals 3x. Okay. Because if we put any of these numbers in here for our x into 3x, wouldn't we get exactly these numbers here? 1 gives us 3, 2 gives us 6, and so on. Negative 2 gives us negative 6. Simply y equals 3x. Which ultimately, is that surprising? Knowing what we know here, if this is little f, big F is the antiderivative. And what's the antiderivative of 3? 3x. Okay. In general, it's 3x plus c here, but ultimately we don't have any add-ons here, do we? 3x will do it, but c would just be 0 in this case. Questions on worksheet number 1. All right. Let's see what happens here with this one. We got this time the number 2 gives us the f function. Notice that the f function here is y equals negative 2, which ultimately we could answer that question right there at this point. Right. And it says on what intervals is f negative? Always. Okay. All right. And then the rest of it asks us about a big F, so let's fill in the blanks. So in this problem, if we go from 2, notice the starting point is 2 instead of 0 this time. If we go from 2 to negative 2, that's going to be a 4 by 2 rectangle, and it's going to be negative 8. However, it's negative 8, but we're going left, so that also ultimately makes it negative negative, which makes it what? Positive. So that value better be 8 right there. Because again, we're going from 2 to negative 2, which normally that would make something negative, but the area itself is negative, so a negative negative makes a positive. If we go to negative 1, from 2 to negative 1, that would be negative 6, but going left makes it a 6. 2 to 0 is going to be a 4. 2 to 1 is going to be a 2. 2 to 2 we know is 0. How about 2 to 3? This time 2 to 3, we're going right, okay? But it's under the x-axis, so it's a negative 2. And then ultimately it would be a negative 4 there. Questions on filling in the chart for big F? All right. How about on what intervals is big F decreasing? Always. And an algebraic rule. Okay. We can see again that the points are linear. Okay. They're going down 2 each time, so that would lead us to believe that it's negative 2x being our slope. Okay. Does negative 2x itself work, though? If I put in a 0, do I get 4? So ultimately, what do I have to do to make an adjustment here? Because again, I know the negative 2x is the slope for these points. It's going down by 2 each time. Okay, what's the y-intercept going to have to be to make these x's give us these y's? It's going to have to be plus what? So just to double check, let's see if it works for this one. If I do negative 2 in here, that's going to be 4. Plus 4 will give me 8. So does it work? You bet. Alright, and ultimately, just to check, is it an antiderivative? Sure. Antiderivative of y equals negative 2 would be negative 2x plus c. In this case, the c just happens to be 4 because of the way the integral is defined here to start at 2 instead of at 0. Questions so far? Alright, let's try this one here. We got this time it's defined from 0 to x. And this time we notice that we have a linear function, but it's not a horizontal line this time. So that means when we find our area from 0 to negative 2, that's ultimately going to be this trapezoid, if you will, right here. Excuse me. So that would be the area from 0 to negative 2. So let's figure out that area. It's going to be 1/2 times the height of it is 2. The two bases are going to be from here to here, that's 6. And from here to here, that's 2. So number-wise, it's just going to be 8. And the question is it positive 8 or is it negative 8? Well, normally we're going left, so it would be negative, but it's below the x-axis also, so negative negative again becomes what? Positive. Okay. The next one, if we go from 0 to 1, it's going to be 1/2 times 1, and the two heights are going to be 4 and 2. And so if I do 4 and 2, that's 6. 6 times 1/2 would be 3. And again, it'd be positive this time because it's still negative. It's below the x-axis, and we're going left. We're going from 0 to negative 1. 0 to 0, it's going to be, of course, 0. How about 0 to 1? If I go 0 to 1, isn't that going to be this triangle right here? Okay. And that would be a 1 by 2 triangle. So it would be 1/2 times 1 times 2, which would be 1. However, that triangle is below the x-axis, so that would be a negative 1. Alright. Now if I go 0 to 2, I'm going this triangle and this triangle. And what do I notice about those two triangles? They have the same area. One's above, one's below, so therefore we'd get what for 2? 0. If I do 3, now I'm going all the way over to here. So I'm going to add to 0 this trapezoid right here, which would be 1/2 times 1 times 2 plus 4. So that would be back to 3 then, wouldn't it? And then if I go over to 4 here, I'm going to add yet another trapezoid here that's 1 by 1/2 by 4 plus 6. It would be a 5. So it would be 3 plus 5 would be a total of 8. Okay. And you notice that what happened in this particular case, the values went down, but then they went back up. And they went back up. So on what intervals is f positive? F is positive from negative infinity to 1. Negative from 1 to infinity. F is increasing on 1 to infinity. And f is decreasing on negative infinity over to 1. Alright, and thinking about what kind of antiderivative we'd have here, we know that the function itself here is a linear function, so the antiderivative should be what kind of equation? Should be quadratic, shouldn't it? Okay. And if you notice, what are the values like? Okay. I mean, you look right there, isn't this the vertex of a parabola if it has these other y values, 0, 0, 3, 3, 8, 8 on either side of it? Okay, right there's your vertex, isn't it? Alright, let's carry on then to the next one, number 4. Let's see what we should have gotten for that one. got another linear function here. See if we can do that same thing and find values for f, big F here. So we're going 0 to negative 1. So it's starting at 0 here. So 0 to negative 1, we're going over to here. So it's a trapezoid. It's 1. So it's a half times 1 times 4 plus 6. So a half times 1 times 4 plus 6 would be 5. And why is it negative 5 this time? Because it's above the x-axis and we're going left. 0 to 0, of course, is 0. 0 to 1. If we go 0 to 1, we're going to get trapezoid again. So trapezoid would give us half times 1 times 4 plus 2. It'll be a half plus times 6, I should say. That'd be a 3 right there. If I go 2, that would be a 4 by 2 triangle. 4 by 2 triangle would be 1 half times 2 times 4 would be 4. Get 4 there. 3, we'd accumulate some negative area. We already have 4 to get to here, and then we'd take off a what? Keep in mind though this is by 2, so it's a 1 by 2, even though the scale is same length. It's a 1 by 2 scale wise. So 1 by 2 would be 1 times a half times 2 would be 1. So this would be back to 3. And then if we go over to 4, we're at 3 here, and we add another trapezoid that's 1 times a half times 4 plus 2 would be another 3. Okay? But ultimately it would be 3 in the negative direction because it's below. So therefore it would be 0 there. Okay. And you might want to take a crack at this without having to do the math. What's this one going to have to be? Yeah, it'd have to be negative 5 again, wouldn't it? Because ultimately this is linear, so we're going to expect to get a parabola. It's got a negative slope, so our parabola should have a negative leading coefficient, should open down. Here's our vertex. We've got 3, 3, 0, 0, negative 5, negative 5. Okay, vertex, of course, here is 2, 4. Alright, so on what intervals is f positive? F is positive on negative infinity to 2. Negative on 2 to infinity. Big F is increasing on negative infinity to 2, as we can see from our chart. Decreasing on 2 to infinity. And then bottom line here says plot those values and what's the relationship between f and big F. So we plot the values. We got negative 1, negative 5, 0, 0, 1, 3, 2, 4, 3, 3, 4, 0, 5, negative 5. And if we plot those points and draw a curve through them, we get exactly what we expected, which is a parabola opening down. And what is the relationship between f and big F? Big F is the what? Is the antiderivative of little f. We could also say that little f is the derivative of big F. True? Questions so far? Alright, let's see what happens on this one here. We got this time we have number 5 has 3 different line segments as the graph. And the graph is still defined as an area function from 0 to x of f of t dt. And let's see if we can fill in the chart here. If we go 0 to 0, of course that's 0. And notice this one's always going right. We don't have any negative values to worry about this time. 0 to 1, we'd have a 1 by 2 triangle. 1 by 2 triangle is going to be negative 1, below the x-axis. 0 to 2 would be a 2 by 4 triangle. 2 by 4 triangle would be negative 4. 3 by 6 triangle would be 3 times 3 would be 9. So that would be negative 9. Go over to 4. We're going, this time, instead of a triangle, we could just add to it this trapezoid. The trapezoid is going to be 6 plus 3, that'd be 9. And half of that, because the length here would be 1, height, if you will. So ultimately, again, we got 6 by 3, half of that would be 4 and a half. So add another 4 and a half to that. We'd be at negative 13 and a half. And then if we add another triangle here to that, which is a 3 by 1, So it'll be another 1.5 to that, so negative 15 at this point. Alright, at 6, we're going from 5 to 6, we got positive area added now. And it's another 3 by 1, so we're at add a 1.5, so we'd be back to negative 13.5. We add another to get to 7. This would be a 2 by 6. 2 by 6 would be 6. So adding a 6 to that would be back to negative 9, which isn't terribly surprising because notice that we're getting mirrored values again here because we have linear functions. That means our antiderivatives here will be quadratic. Once we get to this point, though, we have a constant function here. So that might change a little bit because what we've added here now from 7 to 8 is a 6 by 1 rectangle. True? So 6 by 1, that would put us at negative 3. Another 6 by 1 going from 8 to 9 would put us at 3. Another 6 by 1 going from 9 to 10 would put us at 9. So in general, if we were to graph these, which ultimately we're going to do here, if we were to graph those points, what should we expect? Okay. For these parts here, we should expect something quadratic, because we have two linear functions. And then for this part here, we should expect something that looks linear, because ultimately that piece is constant. So let's answer the questions first, and then we'll see if we can develop a graph here. So f is positive on 5 to infinity.
We say 10, we would stop.
Does it? Actually, yeah, it does stop. Sorry. So we can just go 5 to 10 on this one. Okay. And we can actually include 10 on that because it's clearly positive at 10. Okay. 5 at 0, so I did not include it. Then at negative 1, or 0 to, I should say, 0 to 5 would be negative. And I wouldn't include either one of those because at 0, we're 0 here. Big F is increasing. Not increasing here. We're increasing once we get to 5. So we're increasing on 5 to, and here's where we might be a little bit careful here. Well, I guess we don't because we're increasing all the way through there. So 5 to 10 would be increasing. Decreasing from 0 to 5. Plot the points. So if we go 0, 0, 1, negative 1, 2, negative 4, 3, negative 9. And notice just for that part, what does that look like? It looks like an upside down parabola, doesn't it? Okay, which shouldn't be surprising. What's it coming from? It's coming from a line with a negative slope. Okay. Once we get to a 4, 13.5, 4, 13.5 is going to be right about there. 5, negative 15. Right there. Notice what did that start to do now?
What now?
Started to change concavity, didn't it? Because what are we dealing with now? Now we're dealing with a positive line. So a positive parabola, if you will. 6, 13.5, we've right there. 7, negative 9. Right there. 8, negative 3. 9, 3. 10, 9. So again, you can see how it works here. There's your negative parabola part. There's your positive parabola part. And then what happens once we get to the linear part? These three points are linear to each other, aren't they? Goes up 3, goes up 6, 6, 6, and so on. Alright. So, the next part, what interval is f decreasing? Okay. Little f is decreasing on 0 to 3. Increasing on 3 to 6. Be stationary on 7. Sorry, yeah. 3 to 7, I should say. We can see it's stationary from 7 to 10. How about on what intervals is the graph of big F concave down? Okay, keeping in mind that this little f is the derivative of big F. Okay, we want to know on what intervals is F concave down. Shouldn't that be when little f is decreasing? So it'll be 0 to 3 again. Big F is concave up when little f is increasing. So 3 to 7 again. And again, what's the relationship between little f and big F? Big F is the antiderivative of little f. Or we could write big F's derivative is equal to little f.
How do you know concavity
Well, number one, we can see it. We can see it's concave down because it's going to be an upside down parabola here. Once we get to this point, it changes to a right side up parabola. And then from here to here, it's linear. Okay. But ultimately, again, if this is a picture of the derivative, right, okay, then its derivative is the second derivative. Right? So when its derivative is negative, then f would be concave down, big F. Because ultimately the slopes of this one are the second derivative. Okay? And so we know that, and again, like on this one, the slopes are positive. That means the big F's second derivative is positive, which means big F would be concave up on 3 to 7. Victor?
Wouldn't it be decreasing from 0 to 5? Right?
Which one? This one?
Yeah, because it still has a negative slope. Doesn't it?
We want to know when f is, when little f is decreasing. Little f is decreasing from 0 to 3.
Y values.
Okay. So it's this graph is decreasing. It's going down, increasing from 3 to 7. Okay. Yeah, this is a graph of big F that we've drawn here. They wanted to talk about little f's decreasing, which ultimately little f's decreasing is related to big F's concavity. Good questions. Okay, so what I want you to work on here is we just got through worksheet 1 here. The again the multiple choice problems that we have.